Concept. What is water pressure? Water pressure is the force that determines whether water has a weak or strong flow. The pressure will flow from a point and remain perpendicular to any adjacent surface. Materials. Materials used in experiment. 2-liter bottle, empty, tray, water, enough to fill bottle, drill, something to cut, tape, Sharpie, ruler, and label stickers. Based on the materials before, start with a 2-liter bottle and measure 3 centimeter holes vertical of the bottle, like so. After which you will label the holes like so, A, B, and C. Then take a piece of tape, like this long, to cover up the holes on the bottle, like so. Leave a little tab at the top so it will be easy access to pull it. Now you will fill the bottle with water. After you have filled up your bottle with water, you will now pull the tab and see what happens with the water pressure between each of the holes. Findings and explanation. Findings. From the experiment, it can be seen that the rate of flow at point A isn't as strong as point B and C. Therefore, water pressure is determined by the height of where water flows from. This can be proven from the formula for pressure: height times density times gravity. Explanation. At point A, the height is 0.18 meters. Therefore, pressure is 1,764 pascals. At point B, the height is 0.21 meters. Therefore, pressure is 2,058 pascals. And at point C, the height is 0.24 meters. Therefore, pressure is 2,352 pascals. Using the pressure formulas gives us a better understanding as to how height affects the flow rate of water and how pressure affects it too. The density of water was 1,000 kilograms per meters cubed, and the gravity used was 9.8 meters per second squared. As you can see, as the height increased, the pressure also increased. Effects of air pressure. The role that air pressure, aka atmospheric pressure, had on the system's overall pressure was from the force of the air's weight that lingers in the system. As both atmospheric pressure and water pressures are proportional to each other, i.e., when height is increased in either system, the other one will increase. Air pressure is the exertion of force onto a surface, in this case water. The atmospheric pressure that acts on water has a force of 14.7 psi. Therefore, pressure is increased at every 10 meters depth of water. So in the experiment, as the height increased, hole placement, air pressure increased, causing water to flow out of the holes. However, as water decreased, air pressure decreased, hence why the pressure at the highest point wasn't as strong as the others. This is also why in the video, when the cap was removed from the bottle, water pressure increased. Real-world application. Application 1. Blood pressure. When a person is bleeding, the proper way to handle a bleed, specifically in the arm, would be to elevate it. This is due to how liquid pressure is affected by air pressure. As the liquid is heightened, air pressure will weigh it down, causing reduced inflow. Application 2. A person swimming. They would have to use the implications in this lab to understand that there are limits to the human body. Traveling underwater means an increase in water pressure, indicating that the further down they swim, they would need proper materials to survive.